Hey guys, welcome back to the Python PlayBook series. So in today's video, we're going to be taking a look at basic arithmetic and how to approach it in Python. This is important because when we go on to do the more complicated and more tricky exercises, we'll need to know how to approach doing arithmetic operations in certain situations. So today we'll be covering 7 different types of operations, going from addition, subtraction, product or multiplication, quotient, remainder, logarithms and exponents. Now all of these are relatively simple, but there are a few nuances that we need to clear up. Let's get started. Alright, so I previously mentioned this in one of my last videos, how it's always important, or I always find it very useful to comment my lines of code or my cells before I even start coding, because that allows me to then break down the problem that I have and break it down into steps rather than taking it in as a bulk load. And this will become very, very useful to you when you start doing the more chunkier exercises, because for now, it's fine because we're dealing with 1-line, 2-line codes, which aren't too complicated. But as I said, once we get to the more complicated stuff, then I would say this method is extremely helpful and it's been helping me for a long while with all my types of Python code. But yeah, in this code, we're going to ask the user to give us 2 numbers, 2 integers or 2 decimals, doesn't really matter. And we need to do a set of operations with them, which I just mentioned previously. Now, if you guys remember the process for asking a user to input something, it goes by input followed by the question. Let's quickly do that now. And of course, we want to assign this to a variable so that we can use that in all the other operations we have. So let's go ahead and give a random variable named a. So the first number would be assigned to the variable a. And let's repeat that for the second number, but of course with a different variable this time. All right, so we've got our first 2 lines of code there. Now you might be thinking, all right, we're sorted. We've got our 2 numbers from the user, but not quite. We still have to make a minor change. And I think the best way to show you guys what that is actually by running this bit of code and showing you what's wrong with it. So if we just go ahead and run this first line, we get a question and asks please provide a number. So let's give it a random number of 5. And then for B, we'll just give 10. And now I want to show you guys what the issue is with these 2 lines of code. So the easiest way to do that is just to do a quick, simple operation, which in this case, I'll just add a number onto one of the variables. So I'll add 4 onto the variable A. So if you just go ahead and do that, A plus 4. And let's print it out or display it. And of course, as we remember, to display something, we always do it in print. So if we go and run this now, there we go. So we get an error. So the error states, can only concatenate string, not integer to string. Now what that essentially means is the operation that we've asked Python to do, which is a plus 4, doesn't work because a is not an integer. A has to be an integer to be able to add 4 onto it. Now although we've asked the user to put a number in for a and b, they don't actually count as integers. They are counted as strings. And of course, whenever you count something as a string, you can't do any operations with it, as you wouldn't be able to do with, for example, a word. You couldn't add 2 onto a word because that doesn't make sense. You can only add numbers to numbers. So what we need to change in the 2 lines of code that we wrote, so we need to put eval before the entire line of code there. So if you go and put eval input, and ensure to encompass it in brackets, because if you miss out a bracket, that can also come up with a syntax error, which is essentially like a spelling error, but we'll get onto that in a different video. Okay, so now we've put eval around it, and this, if you run it again, it should ask the user for a number, and this time when the user enters a number, it doesn't go in as a string, it goes in as an integer, and thereby allowing us to do any operation we want with that integer. So let's just go and run it just to show you guys that it works. So run, give 5 and 10 like last time, and then run this once again. There we go, 9, as expected. Okay, so this is very important. Always please remember to put eval input whenever you ask the user to input a number, because if you don't, it'll take it as a string and we can't do any operations with that. Unless you're actually working with strings like a word hello, or if you just want to take a number as a string and not do any operations with it, that's completely fine. You can just use input in that case. But yeah, getting started with our first operation, we have addition. I've kind of showed you guys how to do that. It's very simple. It's just the variable plus whatever, and in this case b, which I can show you guys. So a plus b. If we run that, we should be expecting 15 as per so. Now moving on, we have subtraction. Subtraction is just as simple as addition, obviously with the minus sign, and I'll quickly show you guys that as well. So we do print again to display the answer, and we can do, let's do the bigger numbers minus the smaller number, so we'll have b minus a, and then if we run this now, 5 as expected. So as you can see, addition and subtraction are very simple. They don't have many details to think about, but there are more details to uncover in the rest of the operations. So let's take a look at product, for example. So mathematically, in order to do a product from multiplication, we'd write the multiplication sign, which is just an x. But in our case, or in Python, we do this very differently. So in Python, we represent the multiplication sign with an asterisk. So let's do print and then a times b. So what we would do here is instead of a cross b, we'd have a asterisk b. And now if we go ahead and run that, 50. 5 times 10 is 50. So please remember, whenever you do multiplications or any forms of product, always use the asterisk sign. Alright, so now we have quotient. So for quotient, for those of you who don't know, is essentially asking how many of one number can go into another. So just give you a random example, let's say 3 and 23. How many of 3 can go in 23? So that would be 7, because 7 3's go into 23, thereby giving a remainder of 2. But in Python, we'd represent this by doing a double slash. So let's go ahead and do that. Print, let's just say A divided by B, or let's just do the other way around. Let's do B divided by A. Now, if you run this, this should give us 2, because that is how many 5s fit into 10. Now, conveniently, dividing two numbers is given by 1 slash rather than 2, so there's not much difference. Now, taking a look at remainders, we want to see how much remains after we've divided one number by another. Now, in our case, obviously, because 5 divides nicely into 10, we'd have 0, so we'd expect 0. But in other cases, when you have an odd number divided by an even number, we'd have a remainder. But in this case, we'll see that we should be getting 0. So let's do print, and then in order to get the remainder, the symbol that you have to put in between B and A would be the percentage sign. I don't know why it's like that, but just go along with it. That's what I've learned. So now if we go run this, we should be getting 0, as per so. Now we reach the trickier ones. Now we reach logarithms and exponents. So logarithms are represented by log base e, for example, and then of whichever number you want. Now in Python, whenever you want to use a logarithm, we have to call in the log function. Now this log function can be found within things called Python libraries. Now these libraries contain several things like formulae, constants, functions that we can call in to our need whenever we want and use that in our code. And Python, along with its Python libraries, makes it an ecosystem. Now in this case, we find a logarithm function in the Python library called math. And let's say you're trying to find a certain constant like pi, or for example, and you don't know where to find it. Just put it on Google. Where do I find the pi constant in Python? And then it will tell you the math library, or will tell you how to actually do it. But in this case, I've told you now that the logarithm is in the math library. So what we need to go and do is import math library into our code. Now I always like to import my libraries at the top of my code, kind of structures my code a little bit nicely rather than putting it in scattered here and there, because then I can see exactly what I've imported, and then that'll allow me to correlate that to which line of code I've imported it in. So in this case, I'll put import math, just as simple as that. Now, in order to call the function from that math library, we'll need to actually write it out as math.log. So let's go ahead and do that now. So let's do print, and then we'll do math.log, and then whichever base you want to do the logarithm in. So in my case, I'll do it log base 10, and then within brackets is where we put the number in. So in this case, let's just put in A. So A in this case is 5. So that line essentially gives us the logarithm base 10 of 5. So if we go and run this, we'll see what result we get. Okay, so there we go, we've got an error. I wasn't expecting this, to be honest. This happens a lot in Python. You might be thinking that code's all smooth, it works fine, and then you run it and then boom, you've got an error. Whenever these errors arise, it's always the smallest things that you haven't noticed. Occasionally, yes, you might have completely messed up the code, or there's areas of the code that you haven't done properly, but here it's very, very simple. All we've done is we haven't actually run through the line of code that imports the math. So right now, we haven't actually imported math other than just writing it in a cell. And in order to actually import it, we'll have to run through that line of code. So let's go ahead and do that. There we go, we run that through. And now if you run this line of code, there we go. We've got a result of 0.698. So please remember, if you ever make a change to your code, you either add something or you remove something, always run through that entire bit of code again, just so you know you haven't forgotten anything that you have added in or removed. So thereby Python won't be confused as to say, what's math, or what's this constant? This hasn't been called in, so it makes life a lot easier. Okay, so that was logarithms, and finally we have exponents. So exponents are very simple. They're much like multiplication, but instead of 1 asterisk, we have 2. So let me show you guys. So we have print, and then we do a double asterisk, and then 3. So 4. So in this case, we have a, and then to the power is represented by the 2 asterisks, and then we have 4. So a to the power of 4. And if you run this, we should get 5 to the power of 4, which I can't think on top of my head. Okay, 625. I think that's right. Of course, if you guys want to check these results, well, feel free to check it on a calculator, and you can always make sure that your answer is correct. But those are all the operations I wanted to cover in today's video. They should definitely come in helpful when we go on to cover the more complicated exercises and when it comes to using these actual operations in these exercises and in real life problems. All right, so I hope you guys found this video informative and very helpful. This series is meant as a guide or a beginner's guide to Python. So instead of just teaching you guys like a lecture going through rule 1, rule 2, rule 3, I prefer to present exercises to you guys, real life problems, and then tackle them in front of you to show you how I would approach them. Now we've covered the fundamental mathematics in Python. We'll be moving on to more complicated exercises very soon. Hope you guys enjoyed the video, and I'll be seeing you all very, very soon. Goodbye.